So in this video, we're going to look at the solution to number 11 from our first packet. We're given a pie chart that tells us the different numbers of individuals responding to a survey that preferred each type of TV show. So for example, 525 stated that they preferred comedy, 194 stated that they preferred musicals, and so on. And in the subproblems of this, A and B, we're going to have a sentence that describes a ratio. We're going to need to extract the data from that pie chart and write the ratio in the appropriate form. So if you look at question A here, we're asked to find the ratio of the number preferring comedy TV shows 2. Remember that in ratio problems, 2 is our keyword. So we have the quantity to the left that will go in the numerator of the ratio, and the quantity in the right will go to the denominator of the ratio. So what is to the right of the keyword 2? The number preferring drama TV shows. So if you were writing this out, you'd probably underline number preferring comedy TV shows. You'd go up to your pie chart and say that is 525 people. Underline the number preferring drama TV shows. You'd go up to your chart and see that that is 890, and you would actually write that as a ratio. And that's exactly what I did here. I wrote the ratio 525 over 890. However, remember that when we're representing ratios in fraction form, often we will be asked to actually express those in lowest terms. And lowest terms, or simplest forms, means that the numerator and denominator don't share any common factors. However, when you look at the ratio 525 over 890, hopefully you immediately notice that both of those numbers end in a 5 or 0. And that's what I've described here. Because whenever numbers end in a 5 or 0, that means that they're both divisible by 5. So we can cancel that common factor of 5 from the numerator and denominator. For this step, you can either use long division, or on the TSI test, you might be provided with a calculator that would allow you to do this more quickly. But when you divide 5 into 525, which is effectively canceling that factor of 5, you're left with 105 in the numerator. And in the denominator, when you do that, 890 divided by 5 will give you 178. Now, you might look at that relatively large numerator and denominator and say to yourself, I have to be able to actually simplify this further. Well, the strategy that you would want to use, and you're probably not going to see a problem like this on the TSI test, so it's really just a good exercise to wrap your head around how you would do the problem. Well, remember that reducing a fraction requires you to identify a common factor in the numerator and the denominator. So what tools do we have in order to be able to factor these two numbers? And I'm going to pick the numerator because since it ends in 5, I know that I can factor it down pretty easily in the initial step. Well, I have a factor tree. And what a factor tree allows me to do is to visualize the actual prime factorization of that prime number. Of the number, I should say. In the prime factorization, what that means is you're expressing any number as the product of prime numbers. Prime means that it's only divisible by 1 in itself. And when you have a number factored in that form, that is a unique representation. So I did a factor tree for 105. I know that 105 is divisible by 5 because it ends in 5. If I divide 5 into 105, I get 21. 21, I know that I can factor in terms of 3 and 7. I've circled 5, 3, and 7 since all 3 are prime numbers, and I can write that the prime factorization of 105 is 3 times 5 times 7. So the only way I would be able to reduce this fraction is if it turned out that 178 was divisible by either 3, 5, or 7. I know it's not divisible by 5 because it doesn't end in a 5 or a 0, so I can just check really quickly whether it's divisible by 3 or 7. And if you try to divide 178 by 3 or 7, you're actually going to get a fractional number. You're going to get a decimal if you do that in the calculator. And what that tells us is that neither 3, 7, or of course 5 are factors of 178. And if it doesn't have any of those factors in it, right, since the prime factorization of 105 is 3 times 5 times 7, that means you can't reduce that anymore. So that is probably way more detail than you will need in order to be able to reduce fractions into simplest form on the TSI. We talked about the main strategies that you should use in both the lecture and the previous videos. So the part B of this asked us to rate the ratio of the number of individuals that preferred musical shows to the number that preferred mystery and suspense. If you go back to your pie chart, you'll see that the number that preferred musical shows was 194 individuals. The number that preferred mystery and suspense was 368. When you're trying to reduce that into simplest terms or lowest form, hopefully the first thing that you recognize is that 194 and 368 are both even numbers, right? They end in a 2, 4, 6, or 8, or 0. And what that means is that they're actually divisible by 2. So if you cancel that common factor of 2 from the numerator and denominator, you're left with 97 over 184. And what you can actually show is that 97 97 is a prime number. If you want to do that quickly, I'm going to try to drag my calculator over to show you how you would actually go about establishing this. Basically, what you're going to try to do is divide 97 by all of the whole numbers and see if it comes out evenly, which it won't, and kind of look at the whole part of the quotient. So when you divide 97 by 2, notice that you get 48.5. So that is not an even number, but the number is 45. So let's go up. 97 divided by 3 is also not an even number, but the whole part of the actual quotient is 32. 97 divided by 4 helps to actually type the right thing in here. Sorry about that. You notice that's 24.25. So the key is I'm increasing the number that I'm dividing by. The whole part of the quotient is going up as well. And I know that I actually can't actually, that the number is in fact prime when the number I'm dividing by and the whole part come together. So when I divided by 6, I got 16 and change. When I divide by 7, I get 13 and change. So notice 7 and 13, they're coming closer together. When I divide 97 by 8, I get 12 and change. When I divide 97 by 9, I get 10 and change. And if you divide by 97 by 10, we know it doesn't work. You get 9 and change. But the key point is those two numbers came together. And whenever they come together, you know that that is in fact a prime number. Now, you're probably, again, not going to be asked anything like that on the TS side, but it's just good kind of exercise as you're thinking about the basics of arithmetic to review. So since 97 is prime, the only way you would be able to reduce this fraction is if 97 divided into 184 evenly, and it doesn't. So even though the numerator and denominator are large here, that is actually a fraction in lowest terms. So I will see you all in the next video.